Okay, so I got a recording. So we'll just try doing this like this. So here's one whole square right here. No, I'm still on highlight. Sorry, guys. This is the first time I've used this program. So let me try it one more time. All right, that's going to work. All right. So we're just going to count the number of whole squares again. All right, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we got 27 whole squares. So we got 27. So 27 of those, plus the half squares. So we just got to count the half squares. So let's try half squares. We got one there, one there, one there, one there, one there, and one there. So we've got what? Looks like we've got, I didn't miss anything, right? So we got like 1, 2, 3, 4, 5, 6. So we've got 6 half squares. So if we add 6 halves together, we get 3, right? So we got to add on 3. And then, so then our answer is just 30 square units. I'm just going to leave it as 30. You could put unit squared if you want, or some people will write like U squared. And that would just depend on the units. So whether the grid was set up in meters or feet or inches, it would be inches squared. I think that's probably good enough. I don't know if we need to do example 2. I think you guys got the idea, same kind of thing. So let's leave that one and let's go on to example 3. Now the first thing we got to do on example 3 is we actually got to draw the figure before we find the area, and then we also have to find the perimeter. So let's see what we got here. Hold on, I got to scroll down a little bit for you guys. Again, if you guys want to, if you need to ask me something, just go ahead and unmute and ask me. Okay, so we got to plot these points. So let's see, let's go, we got the point -2, -3, that's point F. So that's 2 left and 3 down. So that'll be F. Then we got the point -2, +3, so that's 2 left, 3 up. And then we have the point 2, 0, which is 2 right, and that's it. So this was F, this was G, this was H. Okay, and then we got to find the area and the perimeter of this triangle. So let me try to draw the triangle here for you guys. I should probably get a ruler, but I think I'll just try to draw it. So there you go, there's our triangle. And so then let's do the area first. That's probably the easy part. So the area, the area formula for a triangle, that was just base times height divided by 2, or 1/2 times base times height. I'll just do it as base times height divided by 2. But the important thing is you got to remember that the base and the height have to form a right angle. They got to be perpendicular. So we can use this side, this segment GF right here. That can be our base. Because that one we can just count, right? So that's just 1, 2, 3, 4, 5, 6 units. So our base is 6 units. And then our height, well, that has to be perpendicular to our base. All right? So it's going to go to the vertex opposite the base, but it has to form a 90-degree angle, so that would just be right in here. And there's our 90-degree angle right there. So again, our base and our height, they are perpendicular. And that one we can just count also. So that one's just 1, 2, 3, 4. So that's our height. And then we just plug that in the formula. So then we just have our area is our base, which is 6, times our height, which is 4, and then divided by 2. So then our area is just 6 times 4 is 24. 24 divided by 2 is 12. So our area is 12 square units. But then we got to find the perimeter. Well, to find the perimeter, we need to add up the sides, right? We're going to add up all the sides. So we're going to add this side, which we know is 6, but then we also got to find these two sides. Well, I think you can see that these two sides are congruent, right? You can see that FH is the same thing as GH. So really, we need to find one of these sides. Pardon me?
Can you scroll down a little bit so we can see more of the triangle?
Oh, you guys can't see all that?
Yeah, we can see some of it, not all of it.
Really? Because I'm looking like it's mirroring from my iPad to my laptop. And then I thought you guys could see exactly what I had on my laptop, but apparently not. So here, let me
see it just fine. I can see it just fine too.
Oh, weird. Try to maybe hit F11 or something on your computer. Maybe that'll maximize your screen. All right, well, let me keep going here. So we got to figure out the distance from F to H. Okay, that distance right there. You can't just count, right? So you could use the distance formula. You know the coordinates of those points. So one thing you could do is you could do, I'm just going to write the distance formula down here. To get the distance, you, let's see, you subtract the x's and you subtract the y's. Oops. And then you square both of those things, square both of those quantities. And then you add them together and you take the square root. So you could use that thing. But I don't think we need to do that. I think we'll just do it with Pythagorean theorem real quick. So let me erase that. So to use Pythagorean theorem, we're just going to make a little triangle here, kind of like this. And we're just going to find the hypotenuse of that triangle, which would be our distance from F to H. All right, well, we can count this side straight across here. That's 1, 2, 3, 4, so that's 4. We can count this vertical side right here. That's 1, 2, 3. So then we could use the Pythagorean theorem. Well, if we're going to find the hypotenuse, that's really quick. All we got to do is take the 4 and the 3, square both of them, add them together, and take the square root. So that would look like this. And that would be the distance from F to H, which would also equal the distance from G to H. Well, if you look at this, 4 squared, that's 16. 3 squared, that's 9. If you add those together, that's 25. If you take the square root of 25, you're going to get 5. So this should be the square root of 25, which is 5. All right. So then we know that this side up here is 5. And the side the distance from F to H is also 5. So then our perimeter is we just add up the 3 sides. So the perimeter is going to be just, the base is 6, and then the other 2 congruent sides are 5 plus and another 5. So we get a perimeter of 16. And again, depending on what the grid is, if it was in feet, that would be a perimeter of 16 feet. So there you go. There's the area, and there's the perimeter. All right, well, I guess we should probably do number 4 on this one also, just because I think that one has 4 points. So let me scroll over and we'll do that. Okay, so this one, well, we got to plot the 4 points. So let's go, the first point is Q, that's negative 4, 0, so that's 4 to the left. And then we got negative 2, positive 4, so that's 2 left, 4 up. And then we got the point 2, comma 2, so that's 2 right, 2 up. And then we have the point 0, negative 2, so that's 2 down. And then let me draw this thing. So what do you guys think that is? What is that shape? If you know, go ahead and unmute and tell me.
Square.
Yeah, that one's a square. All right, now if you wanted to check to make sure that it's a square, you'd want to make sure that those are 90-degree angles. So just really quickly, I'll run through that. We're not going to write it all out. But what you could do is you could say, to get from this point on the left here to this point on the right, you would have to go up 4 and over 2. All right? But then to get from this point on the left, right here, to get from that point on the left to this point on the right, you would have to go down 2 and right 4. Well, can you see that those slopes would be negative reciprocals of each other? The one slope would have been, let's see, I didn't label all my points here. I probably should have done that. Let me do that real quick. So to label all my points, let's see, this one was Q. This one was R. This one was S, and this one was T. So if you look at my picture there, the slope of QR, so if I do the slope of segment QR, that was up 4, right 2, which would be a slope of 2 over 1. And the slope of RS, segment RS, that was down to right 4, which would be negative 1/2. And then hopefully you guys remember that if these slopes are negative reciprocals of each other, so, oh, hold on, I'm off the screen here a little bit. These slopes are negative reciprocals of each other. One's positive, one's negative, and then you just flip them over, right? They're just reciprocals. If that's true, then that's got to be a 90-degree angle at vertice R, or at vertex R. But I don't think you guys are going to make that big of a deal out of it. I think you guys saw already that it was a square, okay? So what we got to do then is just find the perimeter in the area. Well, the perimeter in the area, let's see, the area, let's do that first. So the area for a square, all we got to do is just area equals the base times the height. So I guess it was kind of valuable because to prove that that was that those two segments were perpendicular, because when you do base times height, the base and the height have to form a right angle. So we know from what we did that we have a right angle right here. Well, we don't know the base or the height. We're going to have to use the Pythagorean theorem on both of them again, right? So we could kind of use that. In fact, we can just do it once because we know it's a square, right? So let's find this side length right here. So we're going to use this little triangle right here. So I'm trying to find the hypotenuse of this green right triangle. Well, we can count both of those. So if I count straight up, I got 1, 2, 3, 4. So I know this side is 4. And then I know that this horizontal green side up here is 2 units long. So we got to find the distance from Q to R first. So the distance from Q to R, I take the 4 and the 2, and I square both of those things. And then I add them together, and I take the square root.
You can't see that right now.
All right, I'll scroll it down for you guys. Yeah, you guys got to remind me because I got 2 monitors and an iPad. I'm trying to watch all 3 of them. There you go. So I just found the distance from Q to R, this green segment right here. Thanks for telling me, though. Tell me if I go off the screen like that. So take the 4 and the 2, square them both, add them together, and take the square root. That's what you do to find the hypotenuse. All right, so what does that give us? So that's 4 squared is 16, 2 squared is 4. So we got 16 plus 4, so it's going to be the square root of 20. So QR, oh, I'm off the screen again. There you go. So QR is equal to the square root of 20. Now we could get a decimal for that, but I'm just going to leave it like that for now. Well, it's a square then. So since it's a square, then all the sides are congruent. They're all the same. So that means that this side is the square root of 20. And this side's the square root of 20. They're all the square root of 20. So that means if we're going to do the base times the height, we're just going to do, again, the base and the height have to form a right angle. We're just going to do the square root of 20 times the square root of 20. So we get an area of, well, if you do this, a square root times itself, or if you want to write it this way, it's the square root of 20 squared. But you guys should know that if you do the square root of 20 times the square root of 20, you just get 20. So that's our area. Well then, since we have found all 4 sides, then we can just do the perimeter. We just got to add up the sides. So we're just going to add this side plus this side plus this side plus that side. Well, I think you could see that would be the square root of 20 plus the square root of 20 plus the square root of 20 plus the square root of 20. Or you could just do the perimeter is 4 times the square root of 20. Now we could break down that square root. I'm not going to make you do that right now though. So what we'll do maybe is I'm just going to put it in the calculator. Because you can break down the square root of 20. But I'm putting 4 times the square root of 20 in my calculator right now. And that gives me approximately, so that's approximately 17.9. And that's it for that one. Anybody got any questions on that one? Let's keep going. So on the next page, we have well, what's in the box? So what they're telling you to do in the box is they want you to find the area of that, let me zoom in a little bit. They want you to find the area of that PQRN. All right, so we're trying to find the area inside here. Okay. So what we're going to do then is we're going to find the area of this. Well, first of all, there's no area formula for that. Okay. So since there's no area formula for it, what we're going to do instead is we're going to draw a rectangle that goes through all 4 vertices or corners. So we're going to draw this rectangle right here, this green one. Notice that it goes through all 4 corners. And then what we're going to do is we're going to subtract off this area A right here. That's a triangle. We have an area formula for that. And then we're going to subtract off the area of triangle C right here. And then we're going to subtract off the area of triangle B right there. So if we do that, then we'll just end up with the red part. That's the area that we want. And again, we have area formulas for those 3 triangles. It's just 1/2 times the base times the height. So let's see if we can do this for example, what are we on here? So let's go to example 5. All right. All right, here we go. So we got to draw a rectangle that goes through all 4 corners, okay? So I guess I'll do that in green again. So I'm going to draw a rectangle like this. So there we go. We're going to find the area of that big green rectangle first. Well, for a rectangle, I just do base times height. So let's see. So the base of this thing on the bottom here, I've got, looks like 6 units. And then the height of it, it looks like I got, what do I got, 8 units. So then all I got to do is multiply those together to get the area of the rectangle. So the area of the big green rectangle is just base times height. Again, those both, the base and the height, have to form a right angle. And that gives me 6 times 8, which is 48. All right, well, now we got to find the area of these little, I guess I'll color them in, I don't know, I'll color them in red. I got green and red going here for Christmas, I guess. So we got to subtract off the area of these triangles. Okay, so then for the first one here, let me erase that 6 there. So this, I guess I should number these or something for you guys maybe. Well, they call them A, B, and C, I think, in the example above, so maybe I'll do that. So I'll call this one A, I'll call this one B, and I'll call this one C. So triangle A. So triangle A, that has a base of, what is that, 1, 2, 3, 4, 5. So that has a base of 5 and a height of 1, 2, 3. And that is definitely a right angle right here. All right, and let's label all of these at once. And then triangle B up at the top, that's got a base of 6. So that's a base of 6. And it's got a height of 3. And then the little tiny thin triangle here, the letter C, that one has a base of 4, and the height right there would just be 1. All right, so all we got to do on those is just base times height divided by 2 for all 3 of them. So let's see, so what could we do? So I guess I'll call it, I'll just call it A, I guess. So small a here, that's just going to be 5 times 3 divided by 2. The triangle, lowercase b, that one is going to be 6 times 3 divided by 2. And then the thin triangle there, triangle C, that one is 4 times 1 divided by 2. So the first one is 15 divided by 2, that's 7.5. The second one is 18 divided by 2, that's 9. The third one there is 4 divided by 2, that's 2. So then all we got to do is add those up and subtract them off of 48. So these 3 together, what is that? We got 9 and 2, that's 11, 11 and 7.5, that's 18.5. So then our final answer, that's for the final figure. So again, what we're finding is the area of this figure right here, this one. So the area of that one, that's just going to be, oh, I'm off the screen again. Hold on a second. See if I can squeeze this in here. So the area is going to be 48 minus 18.5. And that's going to be what, 29.5? And that would be your final answer. Any questions on that one? Let's do one more of these, and I think that's it. Then we're done with the section. Okay? So let's try the next one. So same thing again. I got to draw a rectangle that goes through all 4 corners. So it would look something like this green rectangle that I'm drawing. All right. So the area of that rectangle again, that's just base times height. And let's see, it looks like it's got a base of 7 and a height of 6. So we're just going to do 7 times 6, which is 42. All right, and then we need to subtract off these smaller triangles in. So we've got to subtract off this triangle and this one and this one. Oh, we got one more and that one. So I'll label these again for you guys. So I don't know, we'll call this triangle A, this one B, this one C, this one D. Let me erase these out of here real quick. So for triangle A, we've got a, what do we got? We got a base of 6 and a height of 1, 2, 3, 4. And then for triangle B, we got a base of 1, 2, 3, 4, 5, and a height of 2. And then for triangle C, we got a base of 3 and a height of 2. And then for the little tiny one D, we've got a base of 3 and a height of, right there, we got a height of 1. All right. So then we're just going to do the same thing we did on the last one. So the area of that little triangle, lowercase a, that one's just 6 times 4 divided by 2. And then the little triangle B there, the blue triangle, that has a base of 5 and a height of 2, and that's divided by 2. And then the little triangle C, hold on, let me move up a little bit. The little triangle C, that one has got a base of 3 and a height of 2. Don't forget to divide by 2. And then D, the little one, that's got a base of 3 times a height of 1, and then divided by 2. So if I work these out for the little triangle lowercase a, I got 24 divided by 2, that's 12. For the second one, for triangle B, I got 10 divided by 2, that's 5. For triangle C, I got 6 divided by 2, that's 3. And for triangle D, I got 3 divided by 2, and that's 1.5. So then I'm going to add all these together. Whoa, I don't know what happened to me on that one. So I'm going to add these together. So let's see, I got 12 and 5, that's 17. 17 plus 3 is 20. 20 plus 1.5, that's 21.5. So then for my final answer, I'm going to do the area is equal to, the green area of the rectangle was 42. Subtract off the area of those 4 little triangles, that's 21. That's 21.5. And let's see, 42 minus 21, that would be 21, so minus another half. So I get an area of 20.5. And that's it. That's the whole section. Do you guys have any questions on that? Anything you want to ask me? Well, let me stop the recording on the iPad.